Geometry, Unit 6, which is Chapter 4 from the book, Section 5. Are there other congruence shortcuts? Now you remember, in the last section, we talked about the fact that there's 5 of them, and we covered 2 of them, side, 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 and side, angle, side. So we got 3 more to cover today. And the first one is angle, side, angle. If we have 2 angles, and the side between those 2 angles, that's enough information to prove that these 2 triangles are congruent. So triangle ABC is congruent to triangle XYZ by angle, side, angle. When we're dealing with parallel lines, we need to remember that alternate interior angles are congruent. So here, parallel lines, transversal, alternate interior angles A and Y are congruent. I take the other transversal, and I will get, here's our other transversal, and I will get angle B is congruent to angle X. So, got that information there. If we're given AB is congruent to XY, we have 2 angles, a side between them. An angle, and a side between them. And thus we have angle, side, angle. So we can prove these 2 triangles are congruent. So triangle ABC is congruent to triangle YXC by angle, side, angle. Now, why did I start at Y and go to X? Well, I started at A and went to B. Well, look, congruent. One congruency mark to the second, one to the second. That's why I'm going in that fashion. Because angle A is congruent to angle Y, and so forth. All the corresponding parts are congruent. Next, angle, angle, side. If we have 2 angles and a side that's not between them, that also is enough because there's only one possible triangle created from that. So these 2 triangles, ACB, is congruent to triangle XZY by angle, angle, side. So let's look at another scenario. When we're dealing with bisecting lines, we need to remember that bisector means it cuts it in half. So if we have lines that bisect each other, they cut each other in half. So if AY and BY bisect each other, that means A and Y are congruent. Sorry, AC and CY are congruent. BC and CX are congruent. Now, if we're given angle A is congruent to angle Y, we also remember vertical angles are congruent. I actually have enough information to prove this triangle in 2 different fashions. So ABC is going to be congruent to YXC. I can prove this either by angle, angle, side, but I also could do angle, side, angle. Because look, 2 angles and a side. We also have 2 angles and a side between them. So I could prove it by either technique. And our last way we can prove triangles are congruent is hypotenuse leg. When you have a right triangle, if you have the hypotenuse, which remember is across from the 90-degree angle, if the hypotenuse is congruent, and any other leg, doesn't matter which one, are congruent, that's enough to prove the triangles are congruent. So ABC is congruent to XYZ by hypotenuse leg. Now, some of you might be wondering, well, isn't this just side, side, angle? It actually is. Look, a side, and then an angle not between them. that only works, side-side angle only works when it's a right triangle. But we don't call it side-side angle, we call it hypotenuse leg, because only a right triangle has a hypotenuse. Now let's look at another scenario. Sometimes we'll have triangles where there's a linear pair, and if you have one of those angles as a right angle, well, so is the other one. So if this is a right angle, ABC is 90, we know the other one has to be 90 because it's a linear pair. We're given AC is congruent to CX. Well, that's not enough information just yet. We have to remember that when they share a side, that side's also congruent for both triangles. It's congruent, CB is equal to CB because of the reflexive property. So I can say a triangle ABC is congruent to triangle, so ABC, XDC by hypotenuse leg. Now, just because it's a right triangle doesn't mean it has to be hypotenuse leg. We can prove right triangles using any of the other four properties. But hypotenuse leg only works when you have a right triangle. So let's do some more two-column proofs. So we're going to prove triangle ABC is equal to triangle YXC. And we're given AB is parallel to XY, and we're also given AB is equal to XY. So our first statement, AB is parallel to XY, that's given. Our next statement, angle A is congruent to angle Y. Angle B is congruent to angle X. Why can we do that? That is because they are alternate interior angles. I'll just abbreviate there. Next statement, AB is equal to XY. Well, that was given up here, so that's given. So what do we have? We have an angle. We have two angles and a side between them. The triangles are congruent because angle, side, angle. Let's do another two-column proof. So we're trying to prove triangle ABC is equal to triangle YXC. We're given AY bisects BX, and we're also told angle A is congruent to angle Y. That's the typo. That should be angle X. All right. So AY bisects BX. Oh, no, actually, I'm sorry. That was not a typo. That actually is what it's supposed to be. My diagram here is just a little off. So it's not drawn to scale. So AY bisects BX. BC is congruent to CX. Well, that's the definition of a segment bisector. So remember, when something gets bisected, it gets cut in half. So since AY bisected BX, that got cut in half. That's why it's not drawn to scale. You can see BC should be congruent to CX. AY is equal to, angle A is equal to angle Y. That one was given. So angle ACB is equal to angle XCY. So those two angles are congruent. Well, those vertical angles. So now our two triangles are congruent. Well, I've got an angle and an angle, a side not between them. Angle, angle, side. And there we go. That is the end of this lesson.